There's many different ways. I was going to write the word problem. Then I thought, well, maybe for us to be able to save time, maybe write the equation down here for you, and then you can write this down. Don't write this down. If you feel really comfortable with doing this, well then you probably don't have to perform that task. But there is something that is missing yet. It's where I'm going to ask for some input from yourselves. Balancing. Okay, yes, we haven't not balanced that equation yet. That's correct. The equation is correct. We don't know. It doesn't ask for how many moles of water are maybe required, or how many moles of hydrochloric acid are produced, how many grams of hydrochloric acid are produced, how many grams of this. It just gives you a mass of a substance that are two different types of reactants that are reacting with one another, and then that is it. So this is where we can go through everything that we've learned so far. Okay? Although it doesn't start with moles here, it starts with grams instead. You can do a mass to a mole problem, like maybe convert grams of phosphorus trichloride to moles of hydrochloric acid. You could do that. That was early in this chapter. You can change grams of water to grams of hydrochloric acid or phosphoric acid. That was a little later on. That is a mass to a mass problem. Or you can look at these two reactants, and probably the most common question that you would ask for them would be what? What did we just wrap up with? Yes, limiting reactants. Okay? And then what goes hand in hand with limiting reactants is going to be that of a % yield. On pencil and paper, what yield do you calculate? Your theoretical yield. Then you would have to be given one of these two to say what your % yield is. So a little bit of ownership for yourself. Do you want practice with all of those? Or if you are just doing, for instance, a limiting reactant and a mass to a mass problem, that is everything that we've done this chapter.
Sure.
Okay?
So we do everything that's going to be on the exam.
Well, that encompasses everything that's going to be on your exam. A problem like this.
Okay, let's do that problem.
Okay? So you're given your reaction. How many of you maybe do your setup, or how many of you balance it right away? That's, you got to do that at some point. Okay? So with that, there's perhaps two different ways we could look at it, and that would be, do you want to start with your chlorides or your hydrogens? Okay.
Maybe not. I don't know.
Well, how many chlorides are here? And how many are over here? So probably the most logical thing to do would be to put what here? Okay. Then, okay, with that, now how many hydrogens are on the right side? Okay. So, yep, that's true. So what do we got to do to that of the left side? Okay. So let's go ahead and try to put a 3 here. And then see once what happens. But something's not right here. Right. Oh. This is why. I just made the presumption it was phosphoric acid. Okay. Now it's written correctly. This problem actually comes out of a book. So now that you have that, are we balanced? Yep. Okay, phosphorus is 1 each, chlorides is 3 each, hydrogens is 6 each, and then oxygens is 3 each. Okay, so the first thing that we had done for this chapter would be, let's take 225 grams of PCl3. Okay, so then we're going to go ahead and change that to what?
Moles.
Okay, so moles goes here.
If you did a gram to gram, would you go from PCl to H2O, or would you find like PCl to HCl and then H2O to HCl?
What you can do, you're talking about for limiting reactant,
Yeah.
you can just go ahead and change this, 2 grams of that, change grams of this, 2 grams of that, and whichever one's the less amount is your limiting reactant. Yep. Okay, so now, how do we cancel this gram out in our next step? Okay. Right. And your handy dandy calculator. And then phosphorus is at 30.991. 31, okay. Okay, we get about 137. Okay, so 137, we can say 0.35. Okay, so our grams are gone. Now we are in moles of, PCl3. And what do we get with that? 0.65? Okay, so that's what we did about the first few days of this semester. And then how do we want to label? We've got it labeled, but we want to put that there. Okay, and next we would want to do 123 grams water. Okay, how many grams of water would we get? Okay, notice those are now gone, and then with this, okay. Agreed so far? Okay. Now, I'm going to do this we said in class, and then go back that way. Okay? So, what are we going to do with this number now? Change it to moles of what?
H2O.
Okay? Okay, mole ratio, that means what? Okay, there's 3 here, 1 down there. Okay. .95, is that right? Okay. Do we have enough water?
Yes.
Yes, we do. So then you could say this. Okay. And then we can prove that that's the limiting reactant by doing this. Okay. You get 2.28. Oops. It's not water again. Okay, so how much water, or excuse me, we only have 1.65 and you need 2.28. So that tells you anything you're going to do with the right-hand side, you have to utilize this reactant because it's what's going to limit what you can produce on that right side. Okay, making sense? Always. Yeah, we hope so. Okay, so hold that thought. All right, so now with this, let's go ahead and I just made 110 up. Okay, so if this was actually produced 110 grams, okay, now this is something new that we did, well, nothing new. We've done these mass to mass problems, and again, this is our actual yield. So then we want to find the percent yield, which is a mass to a mass problem, or we can shorten it up because we've already gotten into moles of one of these substances. So what can we erase?
One of them.
Right. So our limiting reactant. Now, is it going to be this one we can erase or this one? Okay, so we can go ahead and erase that one. And then if you're saying this is our limiting reactant, are we going to start with 2.28 moles of PCl3? Because that's what we calculated. You're shaking your head no. Why are you right?
That's required.
Because that's what you need. You need to start with what you have. And with our limiting reactant being that, we can go ahead and erase all of this. Okay. And then we can erase all of this. Okay. So how do we extend this problem out a little further then? So we are in moles of PCl3. How can we get to that side now?
4 moles.
Okay. I'm just doing what you said, mole to mole.
PCl on the bottom, H3PO on top.
Okay.
One second, how do you know to start with that one again? For your gram to gram?
Reactant.
Oh, yeah, you have to start with that.
Mhm.
Actually, okay.
Yep. We got a mole to a mole.
Mole on the bottom, and gram on top.
No, my point is, are we done with this one yet?
Yeah. Is it 1 to 1?
Are you sure?
No, you gotta put the grams on
Yeah,
the side.
it is. It's 1 to 1. Okay. So that's now gone. So we're in moles of this. How many grams?
82.
So this mass to mass calculation gives us how many grams?
135.21.
Okay. 135. I'm just going to stop with that since we have 110. So the last thing we can do, our percent yield is calculated how?
Divide them.
Okay. And our percent yield equals what over what? Okay. And then I'm guessing 87% or higher. I don't know. Oh, okay. 81%. Okay. 81%. Okay. So in a quick manner, we have discussed everything that we've done this chapter, mole to mole. Okay. We didn't do a mass to mole, but that's where we could have stopped right here. So we've done a mass to mass, we've done mole to mole again, and we've done the limiting reactant, and we've done the percent yield. All wrapped up in one. Probably the toughest part, okay, some underclassmen are working on this now. Some of it, it's easy to make a mistake there. Okay? It may be easy to make a mistake if you're dealing with sodium oxide. How may underclassmen make a mistake if we say, write this formula? Okay? You were younger once. What do you got to do? Okay? Na, and then what's oxide? Okay? And then this is -2, that's +1. They don't add up to 0, so what do you got to do?
2 sodiums.
Okay? Because the least common multiple is 2. So one of the aspects that we're trying to do this to move forward is in your stage, okay, when it comes to stoichiometry. This is one place you can make a mistake. This is probably one of the more common ones, not balancing this correctly, okay? So can you do stoichiometry without balancing a chemical reaction? No. And if we can't do this part, then you still can't do stoichiometry, okay? So it's a lengthy process, but you young men and women persevered. It was probably a lot tougher for your class to learn this because you were at home. That was not fun. Agreed? You didn't get to see each other's cheery faces every day. Everyone coming to school with a smile on their face. Just like that, right? Just like that. Just see, now we're nodding our head. Yes, yeah. Yep, yep. Well, I picked on the guys. I got to pick on the ladies. Yep. So, and sorry, you two are in the splash zone. I mean, kind of a little close. So I doubt that your sweatshirt stands for phosphorus. We're saying that it does. Okay. Maybe it's
No, phosphorus.
okay.
What
Well,
else
now,
does it stand for? Even from a science class? For
um,
no reason?
okay. We'll catch up to you next time. We'll continue this conversation on what P stands for in just a moment. So, yes. So any questions, please get in and talk to myself.